So here we are back at my own personal office to look at how the biology of a termite mound may have inspired the design of a building. And this is the Eastgate building. And basically the idea was that a termite mound, and here's a larger version, you can see the person standing next to them, they do get very large. And people or scientists used to think that these large structures that were above ground were designed to regulate the temperature below ground, that they would use convection currents to get cooler air into the mound, and hot air would rise out to the top, this little opening at the top called the chimney. So with this in mind, the designers of the Eastgate building thought that they could design a building that would also regulate temperature and would not need air conditioning. The problem is that that's not really how termite mounds work. So they designed the building based on an idea that wasn't really true. And it took a scientist who looked especially into how termite mounds were constructed to learn how these mounds actually function. That scientist's name was Scott Walker, and there he is there. And he figured out what they look like on the inside by using plaster to basically pour into a termite mound, and then you could chip away the dirt and you could see all the stuff that was inside of it. And he saw there was a chimney and these central conduits, and the termites lived below ground in these little things called galleries, and they also had little farms there. And he figured out that they weren't using the mound to regulate temperature, they were using the mound as a gas exchange device. Because just like all living organisms, if you have a bunch of living things here in the bottom, they're going to produce carbon dioxide. And if you don't get rid of the carbon dioxide, it's going to build up to toxic levels. And he found that what was happening here is there was this mixing area between the top of the termite mound and where the termites lived. And oxygen would come in, usually from the wind, and basically exchange gases with the nest. Termite carbon dioxide would go into the air just by basic diffusion, and oxygen would come into the nest. And that would basically keep the air supply for the termites and all their little babies that lived in the nest. So this actually worked like a lung, so if you need a little refresher on how lungs work. We also bring in air by inhaling, and we have these little air sacs called alveoli, and the blood vessels are not really attached. They sort of just kind of wrap around these air sacs, and then as you breathe in, there's an exchange, a mixing area, just like in the termite mound, between the blood vessels of the circulatory system and the air sacs of the respiratory system. So oxygen moves in and carbon dioxide moves out through diffusion. So back to the Eastgate building, was it biomimicry or bioinspiration? And probably the original idea and what was described in many of the resources was that it was biomimicry. It would attempt to actually mimic what a termite mound was doing to maintain temperatures. The problem is that it's really not what termite mounds were doing. So probably at this point it's more accurate to call it bioinspiration, because they were inspired by what the termites were doing and they thought they had a good idea, and they used that to design a building that didn't need air conditioning, and they'd use fans to basically keep airflow in this building. So on a closer look to the building, here's what the inside looks like. You have the central, really large area for venting, and fans try to bring in cool air, and then they vent the hot air that's produced by the people that are in the offices out. And also the building's made of concrete, which is kind of resistant to temperature changes. And it does work. I mean, it does keep the building cool, or at least comfortable enough to work there, and it requires about 10% less energy than a building of its size. So maybe they didn't get the termite right in the first place, but certainly we can learn a lot from nature and be inspired and think of ways to make buildings more efficient. Or maybe we can just use our biological models to just come up with better spaces so that we don't end up with a space that just doesn't work, because I don't think ants would have this problem. And thank you for listening.